Hi and welcome to this new video. Today we're going to talk about PyTorch Lightning, and that is a library that is on top of PyTorch. It helps you to streamline the training flow a little bit. So we're going to look at an example of one of my previous videos where I showed you how to set up a normal PyTorch training flow to train a binary classifier. And here we're going to do the very same thing, and we're going to use PyTorch Lightning, and it will make it quite visible what the advantages are of using PyTorch Lightning. I link the video in which I went through the original training flow into this description. You can check it out, but also if you just watch this video, everything will be contained in here, so you're not missing too much. And also what I want to show you today is a little tool called TensorBoard. TensorBoard is a library that lets you analyze your training data. It provides a little GUI that also runs inside Jupyter Notebook, and so that makes it quite nice and easy to browse through your training data and analyze it. So let's get into it. As a first step, what I usually do is install all the dependencies that we see here, right? So we pip install it. You can do that outside of the Jupyter environment, but I just do that here in the first cell. Make sure to run that exclamation mark before the pip command. And if you don't want to log out all the installation logs, it helps to just kind of, return it to a value, like an underscore value. So all that is done. And now I'm importing what I need for this flow here. And just like before in the other video, what I like to do is to create some mock data within the Jupyter Notebook, right? So there is a bunch of data out there that you could import in our sample data sets, but sometimes links change and then these notebooks don't work anymore. So I want you to, when you get the code from my GitHub repository, I want you to be able to just run it and not have to worry about, oh, do I have the right data? How does it work and all that? So what we're creating here in this function is a mock data set, just like before. It takes random samples of X, Y coordinates, and then based on whether they find themselves within a circle of radius 0.5, they get a different label inside versus outside, right? So if I run this and then create about 10,000 data points here and then chart that, then we see exactly that, right? So we have this random sample of points, and then the different labels represent the different colors. And that means, yeah, we have inside point, outside points. Now, what we like to do when we train binary classifiers is to stratify the sample. That means we want to have an equal amount of points inside as well as outside the circle. So of each of the labels, we want to have roughly the same amount of data points. And that is what this function does here, creating a stratified mock data set. And if I do that here, just kind of 200 data points as an example, you could roughly eyeball here that you have about the same number of points outside the circle as you have inside the circle. And so this is very helpful when you train classifiers, right? Make sure you have the same number of data points for each of the classes you want to detect. Okay, and then just like before, PyTorch mock data set, what you usually do is you take in some data, you define how it is then distributed when you actually run that in a data loader. And here's what we're going to do. We're going to create our mock data set. The training data set has 10,000 data points. Our validation data set has 500 data points, right? We need much less for that. And now we get into the new stuff. Okay, PyTorch Lightning. The first cell, that's self-explanatory. We have a learning rate, we have a batch size, and now we're creating our multi-layer perceptron class, right? So you see the first line, we no longer now subclass of torch_nn.module. We're subclassing the Lightning module. And some things change. We'll have to implement certain methods, but the init is just like before. We are creating our architectures, right? We have the different layers here, input layers, hidden layers, and then an output layer. You see here the output layers. All of these are linear layers. The output layer maps everything into two neurons. So for the two classes that we want to detect, inside versus outside the circle. Then we override the forward method that really declares when you run the model on an input tensor, what should happen to then, result in the output tensor. And so what happens is, of course, we run it through all of our layers, the input layer, the rectified linear unit, the hidden layers, batch norms, if we choose to do so, and then all the way to the output layer. Now here comes new stuff. We configure the optimizer in this class, right? So usually you need an optimizer, either gradient descent or other optimizers. The Atom optimizer is what I usually use by default. We pass all the model parameters into it and a learning rate. And then this method has to return that optimizer. So that's all happening in here. And then we define what should happen in each training step. So instead of writing a training loop and writing it there, this all goes into one method, right? So we get a training batch. We can also use the ID, but we just need the batch. It is a tuple of X and Y data. That's what we defined in our dataset class. We run the model. We're still in the model class. We can just run self on X, make our prediction, Y hat. We calculate the cross entropy loss for that batch, and then we log it. This logging goes to TensorBoard. This is what we look in, but also this class needs to return the loss. So this is how PyTorch Lightning knows what is the actual training loss. Now the validation step looks very similar, and the only thing is we're logging validation loss when we send it to TensorBoard. All right. So this is how we declare our model. So it's nice and compact. And now we can run our training. So no more for loop for how many epochs and all that. It's basically contained in these lines. The first step is, again, data loaders from the data set. So we pass in our data sets that we created, our batch size, that is the size of each batch when we run through the training. And for training, it's always good to shuffle the data through each epochs. For validation, we want to keep the batches constant, so we get a reliable metric. So we're creating our data loaders. And now we're setting up the trainer. So there is a couple of parameters you can set to the trainers. Right now, I'm just saying, okay, I want to train 10 epochs maximum. We are training on a CPU today, but if you have a GPU available, you can actually set that parameter here as well, and then you're training on a GPU. Now, the cool thing is, you may have noticed, we no longer have to do anything like sending our tensors and our modules to device, like on a GPU. This is also something that PyTorch Lightning handles for us. So no more, to device and all this. This is great because it doesn't really add any informational value to someone who reads the code, but it has to happen. So it's great that PyTorch Lightning takes care of it. But in either case, today we're going to be training on a CPU, right? So I don't have a GPU available on this machine. That's okay, because this is actually something you can easily run on a CPU. And now we are setting up our model, right? This is the call, sets our architecture, and then trainer.fit model, training data loader, validation data loader. That's all that needs to happen. And now it's running, right? So it's counting here epoch by epoch. It also gives you this overview of how many parameters it's training. This is a very small model. It only has 78 trainable parameters, but it's good to just show you what the flow is like. And then here is a little bit of an interesting something that I could consider, right? So it's telling me that right now the training step is not the bottleneck. It's not the CPU trying to train the model that is too slow. It's actually the data loader getting the data to the CPU. And of course, that's not what you want to have happen, especially if later you train on a GPU. You don't want to be bottlenecked by the process of getting the data to the GPU, right? So what it tells you to do here is to just let the data loader know that it can use more workers to parallelize the work, right? And that would actually accelerate that and improve this. So it's good to know that. We can kind of consider that. But now here, the training has stopped. And as of now, that's all you're left with. You know now that your trainer has completed the 10 epoch training. It's not at 0, so it's here at the end of the number 9 epoch. And it put all the logging data in a subfolder in the same directory called Lightning Logs. And TensorBoard now, with these commands, lets you open these logs inside the Jupyter Notebook, right? And it gives you this really nice GUI here that you can go through. Today, we're just going to look at our training loss, but you see you can actually log images, scalars, get histograms and all that. But today, we're just going to look at how the training loss progresses. This first chart doesn't really tell you much. So for each step, after each batch, it tells you what epoch it's still in, right? And so naturally that is linear increasing all the way to epoch 9, starting at 0. So no real information there, but that's how it's being logged. Training loss, that's getting interesting, right? So training loss overstep, and you get kind of like a point for each epoch, right? This is epoch based. I like to also just put on this on log scale, right? It gives you this little bit more plain view of, okay, how the training loss is progressing. It's progressing quite well, actually. And you see here, it's coming down, right? So that's great. You have a few more cards here. This is training loss, basically at the step level resolved, right? And this is very jittery. Each batch has like a different loss. So this is not a great visualization. I don't like to look at it that way. I like to look at averages for epochs. And then we have the validation loss based on an epoch. And that's quite nice too. So you can see how that is progressing. And I also want to toggle that. And you see it's kind of coming down here to 0.2. So if we run this training again, and maybe we'll run it, let me see, we'll run it slightly longer. Let's say we want to run it for 15 epochs, right? And we're gonna run that again and fit it. And so again, this is happening. Oh, we could have done this now to our data loader. That would have come in here, right? So we would have done this number of workers, and that would help us, but now it's too late. It's already running. And I see epoch 4. So we're going to run a little bit longer. And I want to show you that once we have these two runs, we can actually compare them in TensorBoard, which is nice, right? So usually you iterate a little bit, you change certain hyperparameters, and then you want to compare, is this progressing better or worse, or what is happening, right? So that's good to have. So we're going to wait a few more epochs. And if you're wondering where this number is coming from, 313, remember that we have a batch size of 32 and we have a total number of 10,000 data points in our training data set. So naturally, you have basically 10,000 divided by 32 steps that you have to go through for the training. So one epoch is 313 steps. So now at the end of epoch 14, we should be through with that, almost there. This is the last one. And now I am very curious what this is going to look like. I'm going to restart and log that. And you see now we have two runs. It's called as a version. We can check and uncheck those. Again, the same epoch that is not really telling us much. But here, okay, cool. So training loss, log scale. Okay, well, it started a little bit better. It's not really coming down. So to be seen if longer training runs would help here. How about the validation loss? All right, let's look at this. Okay, looks somewhat similar to, it's this, yeah, you see it could still kind of be trending down here. So we would get more insights by simply letting the training run a little bit longer, maybe toggle some hyperparameters and then compare run by run what works and what doesn't. So now I hope you found this helpful. I hope this gave you an overview of how PyTorch Lightning makes your training flow a little bit more streamlined, how your code is more compact, more readable. This also has shown you a little bit how to use TensorBoard and how to analyze training runs in TensorBoard. It's a very nice utility. Let me know in the comments if any of these you would like to dive in deeper. I'm happy to make a video on like TensorBoard and go into all the functionality because it has a lot of cool features. So let me know. In either case, I hope you enjoyed this video and I hope I see you in one of my next videos. Until then, have a good day. Take care.